Welcome you all students. For this lecturing video session, I am going to solve a problem from epicycloid. Let me just read out the question to understand it and extract the maximum information from the given question. Draw an epicycloid. So, clearly specifies here this particular curve would be an epicycloid of a circle 40 mm diameter which rolls outside of another circle of 150 mm diameter for one complete revolution in clockwise direction. Draw a tangent and normal to it at a point 95 mm from the center of the directing circle. By the way, what is epicycloid? Epicycloid is a curve traced by a point on the circumference of the circle which rolls over the another circle or outside of another circle without slipping, which means suppose this is the directing circle, this is directing circle or base circle. Over this generating or rolling circle starts rotating in clockwise direction to complete one full revolution. This is the contact point. When it starts rotating to complete one full revolution, it would trace some points in the space. So, by plotting those points, we will get the curve, which is nothing but the cycloidal curve. This is epicycloid, right? This curve is epicycloid curve, right? This is what I am going to construct here, right? So, let me just extract the information from the given question. Draw an epicycloid of circle 40 mm diameter. So, given data, the diameter small d 40 mm. Therefore, R is equal to d by 2, 40 by 2, which is 20 mm, right, which rolls outside of the another circle. That means this could be the rolling circle because which rolls outside. That means this particular diameter circle rolls over the another circle. So, therefore, this is dia 40 is a rolling circle diameter of another circle 150 mm diameter. So, the capital D equal to 150 mm. Therefore, R is equal to D by 2, 150 by 2 equal to 75 mm, equal to 75 mm to complete one complete revolution in clockwise, right? Fine. So, how to identify whether this curve pertains to epicycloid or not? Suppose this particular word is not there, right? Draw a curve of circle, suppose it is mentioned, draw a curve of a circle 40 mm diameter which rolls outside of another circle of 150 mm diameter for one complete revolution. Suppose it is given. How would you find it? So, as I taught you the sample diagram of epicycloid, what it says, this rolling circle rolls over the another circle, outside of the another circle. So, the word, you will have to look at the key word. So, what are they? The word outside, the word outside of another circle, over another circle, external, when it starts externally, over another circle, above another circle, above another circle, then the rolls on the convex side, rolls on the convex side. So, this word, if these words reflect on the question, then you will come to know, okay, this question pertains to epicycloid. Right? Fine. First, I need to start constructing the epicycloid, for which I need to know the distance of OC. O is the center of the, this is what the diagram, isn't it? So O is the center of the epicycloid and C is the center of the rolling circle. I need to know this distance OC. So OC is equal to R plus R. Look at here, this would be the radius. This would be radius of the base circle or directing circle, and this would be the radius of the rolling circle. So OC is equal to R plus R, which is equal to 75 plus 20, which is equal to 95 mm. Right? Let me just start constructing the curve epicycloid. Fine. So choose any point. Choose any point. Right? And this as O. This as O. And at any given angle, any angle, take on your own any angle of distance 95. Of distance 95. This is C. OC is 95 mm. So, not necessary that you have to take on this angle. You can take this angle also, horizontal also, your wish. Right? So, this is the initial position where the rolling circle starts rolling over the base circle or the directing circle. So, OC has been drawn. Now, C is the center of rolling circle. What is the rolling circle radius? 20 mm. Now take 20 mm in your compass. C as center. C as center. Go for a full circle. Go for a full circle. 20 mm as radius. Go for a full circle. Full circle. Right? So this is the rolling circle. This is the rolling circle, right? This is a rolling circle. Extend this. Now I am going to divide this rolling circle into 8 equal parts, as we did for the cycloid, right? What I did to construct the cycloidal curve, that is cycloid, I had divided the rolling circle into 8 equal division. Similarly, that base line or directing line I have divided into 8 equal division. The same method I am going to follow here. I am going to divide this rolling circle into 8 equal division. So now this is the C is the center, right? Now keep your protractor in this manner. Choose 90 degree. Draw a line here and extend it. Now I have divided this rolling circle into 4 equal divisions. Now I need to divide 4 more. So for which, let me just keep the protractor in this manner. Choose 45 degree. Similarly here 45 degree. Now this choose an angle that is 45 degree passing through the center of the rolling circle. Extend it. Similarly passing through the center of the rolling circle. Right. See, as I taught you, the contact point of rolling circle and the directing circle should be taken as point number 8. So this could be 8. See, as far as the epicycloid is concerned, assume this is rotating the clockwise direction. It is mentioned the clockwise direction. If the rolling circle rolls on the clockwise direction, the numbering could be anti-clockwise direction, that is counterclockwise. So this could be 1, 2, 3, 4, 5, 6 and 7. Fine. To complete one full revolution over the directing circle, it would have made some angle, isn't it? How to find that angle? There was a formula which I taught you in the introduction video, right? Theta is equal to small r by capital R into 360 degree. 360 degree. What is the value of small r? Which is 20 divided by 75 is the capital R radius. So 75 into 360. So which works out 96 degree. Which works out 96 degree. Now what you have to do is take your protector and keep it at O at 7 angle. Fine. Now this would be 90, therefore 96 would be somewhere here. Now extend this line passing through 96 from the point O, extend it. Right? Extend it. Fine. Now what I am going to construct it, I am going to draw the concentric arc where the rolling circle rolls, isn't it? So let me just take O8 as radius, O8 as radius and O as center, cut an arc till it intersects the line which has been drawn at an angle of 96 degree, at an angle of 96 degree. So keep it at O8 as radius, draw an arc. It's a thin line. Now O7 as radius, O7 as radius, O as center, start making an arc which would pass through 1, which would pass through the point 1. Fine. Now change the radius, O to 6, O to 6, O as center, draw an arc till it intersects this line which has been drawn at an angle of 96 degree. When you just draw it, it will pass through 2, point number 2. Got it? Now O5 as center, O5 as center, draw an arc which will pass through 3. Draw an concentric arc. Fine. Now O4 as radius, O as center, draw an arc till it intersect over there. Right. So what is the center of this rolling circle? C. Right. So I need to show the locus of center. So for which, let me just take the radius from OC as radius. OC as radius. Now let me just draw a circle. OC as radius. Let me just draw it. So center should be the notation of, or the axis or the center should be always mentioned long line, short line, long line dot or whatever, long line dot long line, isn't it? So similarly in that same manner I am going to mention here long line dot, long line dot, long line dot, long line dot, long line dot. Right. So now what I did was I made a circle representing the rolling circle, then taken 96, that is the sector where the rolling circle completes one full revolution or one full convolution, right, over the directing circle or the base circle. So this is the path where the rolling circle rolls to complete one full revolution. Since I have divided this particular rolling circle into 8 equal division, I need to divide this particular sector into 8 equal division. Fine. So for which what I am going to do is, so this is two extremes, 4 or this one you can take the extreme points, or let me just take this 8 and this as the extreme point. Both are same. If you take this to complete the bisecting method to divide this particular 8 division, by implementing the bisecting method, right. So, take more than half of this, cut an arc. Similarly, keeping at this extreme point, cut an arc. Now, draw a line from O passing through this intersection, So, now I have split this particular segment into 2 equal divisions. What I have to do? I have to split into 8 equal divisions. Now, going to take this as my sector. These are 2 extreme points, keeping the compass at this point, stretching out, taking more than half and cut an arc here. Similarly, keeping at this extreme point the compass, cut an arc here. Now draw a line from O passing through this intersection, Look at here. I have split this into 2 equal divisions. Further, this particular segment I need to split into 2 equal divisions, for which these are 2 extreme. By using the bisector method, keeping the compass here, stretching your compass, taking more than half of this arc, cut an arc here and changing the center, that means the one leg on this extreme point, cut an arc here. Now, draw a line from O passing through that intersection point, In the same manner, I am going to repeat to bifurcate or split or divide, right. Now, this is my 2 extreme points, keeping the compass here, taking more than half of this, cut an arc here. Change the position, keeping the compass here, cut an arc here. Now, this is the intersection. Now, draw a line from O passing through the intersection. Look at here. The one half of this particular segment has been divided into 4 equal divisions. Similarly, this portion need to be divided into 4 equal divisions, for which this as my extreme points, stretching the compass, taking more than half of it, cut an arc here, keeping the compass here, cut an arc here. Now, this is the intersection. From O, draw a line passing through the intersection. Now, this has been split into 2 equal divisions, right. Now, this is my extreme points, stretching the compass to take more than half of this particular arc, cut an arc here. Now, change the location of the compass and keep one leg on this extreme point, cut an arc here. Now, from O, draw a line passing through the intersection, right. Fine, this has been divided now. This is the portion, finally I have to divide into 2. These are 2 extreme points, keeping one leg of a compass here, stretching it to take more than half of this arc, cut an arc here. Now, keeping the compass at this extreme point, cut an arc here. Now, draw a line passing through the intersection. Look at here, how many divisions? 1, 2, 3, 4, 5, 6, 7, 8. This particular segment has been divided into 8 equal divisions. Now, where is the directing circle? This is nothing but the rolling circle or generating circle, isn't it? Or generating circle. Fine. Where is the base circle? Yeah, here it is, the base circle. This is base circle or directing circle, isn't it? Base circle or directing circle, this one. So, in cycloid, remember, you have given the numbering for rolling circle 1 to 8, 1, 2, 3, 4, 5, 6, 7 up to 8. And for the baseline, that horizontal line, we have given the naming as 1 dash, 2 dash, 3 dash for baseline or the direct line. Here for the base or directing circle, I am going to give the naming as 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash. So, if you have any confusion, what you can do is you just draw the sample diagram here. So, this is how it's rolling. So where is your base circle? Here. Look at here. It is below the rolling circle. Therefore, this could be your base circle. And this is rolling circle, isn't it? Right. Now, center, the bifurcation which I have made, that means 8 equal divisions of the particular sector, where it intersecting the locus of center, I am going to take this as C1, this as C2, C3, C4, C5, C6, C7 and C8. Got it? Right. C, that is the center of the rolling circle. So I have drawn an arc which represents the locus of the center. This bifurcation, that is this particular segment has been divided into 8 equal sections which intersects the center of the locus, is named as C1, C2 up to C8. So now I am yet to construct the curve where the rolling circle rolls on the directing circle, right? So as I taught you, so as far as the cycloidal curves like cycloid, epicycloid, hypercycloid, here the center varies, radius is fixed. What would be the radius? Because the rolling circle is the one which rolls over the another circle, therefore one should take the radius of the rolling circle in your compass. So taking 20 mm in your compass, C as center, cut an arc, it will intersect here. So this point can be named as P. Now change the center, C1 as center, where will have to cut? This represents 1. So therefore, where the line 1 is there, there will have to cut. So keeping at C1, cut an arc on line 1. So here this is the line. So this one can be taken as P1. So now change the position, C2 as center, radius is nothing but the rolling circle radius which doesn't changes, right? So C2 as center, cut an arc on C2 as center, cut an arc on line 2. Where the line 2 is here? Somewhere here. So this point can be taken as P2. Now change the center, C3, without changing the radius, cut an arc on line 3. Where line 3 is? So line 3 is somewhere here. So this point can be named as P3. So now C4 as radius, C4 as center, cut an arc on line 4. Look at here, line 4 is somewhere here. So this could be P4. Now change the center, C5 as center, cut an arc on line 5. Where line 5 is? Here. It is coming over here. So cut an arc. So this could be P5. That is P is nothing but point, right? This is the point which this particular rolling circle is tracing. So C6 as radius, cut an arc on line 6. Where 6 is here? Yeah, somewhere here. This could be P6. Now C7 as radius, cut an arc on line 7. So line where the 7 is here? Somewhere here. So this could be P7. C8 as center, cut an arc on line 8. So this could be point 8. So now what I did was I have just marked those points where the rolling circle rolls over the directing circle or the base circle. Now I am going to plot all the points which I have traced, right? Starts from point 8 and passing through, that is P, P1, P2, P3, P4, P5, P6, P7, P8 to complete the curve. So starts from P, draw a smooth curve, passing through all the points, by using free hand. Once you are confident enough that this particular curve is being constructed in a smooth curve, then you can change the pencil as HV or H. Then with free hand you just draw the curve over the thin curve which you have constructed. Right. This is nothing but the epicycloid curve. Right. So, I have completed the construction of this epicycloid curve. Right. Now, what is left? I will have to draw the tangent and normal at a point 95 from the center of the directing circle. Where is the center of the directing circle, or where is the center of the base circle? O is the center of the directing circle or base circle, isn't it? Right. So, now take 95 in your compass. Take 95 mm in your compass. O as center. Cut an arc on the profile, that is on the curve. So, rotate somewhere, it intersects somewhere here. Right. This point, let me just take this as 1. So, remember, you just recollect it as far as the cycloid, when I constructed the cycloid, what I did, I mean, how I constructed the tangent or normal, chosen a point, isn't it? Then taken the radius of the rolling circle, cut an arc on the center of the locus, then I extended till the base line. Then the base line to the chosen point, I have drawn a line. The same manner I am going to do here to draw the tangent and normal. So, the point has been chosen, 95 mm from the center, cut an arc, chosen the point 1. Now, take 20 mm in your compass, that is the rolling circle radius. Keeping at 1, cut an arc on the center, locus of the center, and this as point number 2. If you want, just draw a thin line. Then, you have to draw the parallel to the line which has been bifurcated. So, here look at here, O phi dash. So, I have to draw a parallel line to O phi dash, right? Draw a line till it intersects here, till it intersects O. Somewhere it intersected here, isn't it? So, you will have to extend it till the base circle or the directing circle. This point is considered as point 3. So, if I join the point 3 and 1, what will I get? I will get the normal. So, passing through point 3 and 1, this is nothing but n dash is normal. Then what about tangent? Tangent would be perpendicular to the normal. So, keeping at point 1, keep your protector, sorry, not in this manner, you have to keep the protector in this manner, choose 90 degree and draw a line passing through the point 1. So, this is T dash, this should be 90 degree. Got it? So, first what you have to do to draw the tangent, here it is given 95 mm. So, from here cut an arc on the profile, then taking the radius of the rolling circle at the given point, cut an arc on the center of the locus, then extend the line which should be parallel to the 0 to 5 dash or 0 to 6 dash till it intersects O. The line which you extended, it intersects the base circle or the directing circle, that is point number 3. By joining 1 and 3, you will get normal. So, if you draw a line perpendicular to normal is nothing but the tangent. So, by doing this, I have completed the construction of the epicycloid curve. So, what are they? What are the things should be drawn as dark? 3 things, right? I taught you in the beginning. The profile, that is the epicycloid curve, tangent and normal. Only 3 things should be drawn by using H or HP pencil. Rest everything should be drawn by using 2H pencil only. Since I completed the construction of the epicycloid curve, now I need to give the dimension for it. So, for this particular rolling circle, I am going to give the leader line in this manner. So, specifying with arrow dia 40 mm, dia 40 mm, right. Then what about the radius of the rolling circle, the base circle or directing circle? which is 75 mm. So here it is, right? Now draw a line perpendicular to this. Perpendicular to this. Similarly, at the end, perpendicular. Now draw a line parallel to OA dash. So which is the radius of the base circle or the directing circle. Then one more dimensioning, which is 95 mm from the center of the directing circle. So this distance, how this can be mentioned? For this line, draw a perpendicular. For this, draw a perpendicular line. Right? Sorry. Draw a, because these are parallel, isn't it? These lines are parallel, therefore the perpendicular line could be somewhere here. Now, from here, draw a perpendicular line to this. Perpendicular line. Now, parallel to this. This could be 95 mm, isn't it? This could be 95 mm. 95. I have completed the dimensioning. So, what are the things which is left out? So, the node which I need to specify. The node which I specify. So, always remember, below the right bottom of the drawing you should specify the nodes, since I don't have sufficient space over there. So, that's why I mentioned here. Drawing a guideline of 5 mm height, n dash as normal, n dash as normal, then t dash as tangent, then the scale what you have considered, since I haven't changed any or I haven't considered any special scaling, that is reduced scale or the enlarged scale. As it is, I have taken the dimension what is given in the diagram. So therefore, I use the actual scale, so which is nothing but the true scale 1:1. Then the dimension which is specified here. So 40, 75, 95 are, what is the unit of the dimensioning? Or mm, 40 mm, 150 mm, 95 mm. So which I need to capture here by drawing the guideline. All dimensions are in mm. All dimensions are in mm. Are in mm. Fine. So let me just recollect it, how to identify the epicycloid. If any word which reflects on the question outside, over, externally, above, convex, that means a circle which rolls outside of the another circle, or a circle which rolls over the another circle, a circle which is externally rolling another circle, a circle which rolls above the circle, a circle which rolls convex side of the another circle. So if this word reflects, definitely the curve could be epicycloid. For epicycloid, they would specify two radius. One is for the rolling circle, the other one is for the directing circle. Hope you all understood how to construct the epicycloid. Thank you.